Happy Friday, April 9th. Today's learning objectives will be to find the area of polygons. We'll figure out what a polygon is soon. I can decompose polygons to find the area by creating shapes we already know how to find the area for. So example, shapes that we already know how to find. We have rectangles, squares, triangles, parallelograms, trapezoids. Those are the shapes we already know how to find the area for. So we're going to decompose polygons to those shapes. You should have already completed Math Olympics event number 8. Again, this is what we're going to be doing is finding the area of polygons. And yes, I know you looked at it right away. We have homework on a Friday. Math Excel 13-5 polygons. Make sure you have out a pencil, calculator, notebook, and the guided notes from yesterday. Let's start with part 2, hexagons. And a hexagon is a 6-sided shape, but it says a regular polygon is a polygon with all sides of equal length and all angles of equal measure. You can decompose a regular polygon to find its area. So without reading this information here, anyone have any idea how we could decompose this polygon? I see 2 ways to do this. The 2 ways that I see are, 1, we can create triangles by connecting the vertices to the midpoint. So we do all this for each vertice to the midpoint. The midpoint is equal distant from each vertice. So these lines that I'm creating, they are all equal. All right, so if we are given the length here and we're given the height of the triangle, we can find the area of the hexagon. How we find the area of the hexagon would be finding the area of one triangle. Area of a triangle equals base times height divided by 2. That's how we would find the area of one triangle. Then we're going to multiply that by 1, 2, 3, 4, 5. Well, I'm sorry. 1, 2, 3, 4, 5, 6. Multiply that by 6 triangles. That is going to equal the area of the hexagon. So again, find the area of one triangle, multiply it by 6. Okay, again, that's one way. There is another way. Does anyone see it? They think they know. Think back to yesterday. What did I do? I just cut this into, yes, 2 trapezoids. Back to our trapezoids. We have base 1 plus base 2 times the height divided by 2. Okay. In this case, since we're finding 2 trapezoids, this one could really flip over and be one big parallelogram. So we don't have to divide by 2. But to find the area of one trapezoid, you would have to divide by 2, and multiplying it by 2 to find both. So it's kind of doing the inverse of each other, so it's not necessary. Okay, so again, area of a trapezoid equals base 1 plus base 2 times the height divided by 2. That's another way to find the base. So in this problem, they will give us this length, or one of these, this one, this one, or this one. They're all the same. They will give us the distance from the midpoint to here. If they give us that, we can double it to find the other way. And that's your 2, your base 1, and your base 2. They should give us a height, would be your height here, and divide by 2. Find the area of one trapezoid and multiply it by 2 to get both of them. So those are the 2 ways you can find the area of a regular polygon or a regular hexagon. Okay, let's go ahead and try this one. I want you to give it a shot on your own, but let me talk a little bit here real quick. It says decompose the regular hexagon into 6 matching triangles to find the area of the hexagon. So going back up to this one we did, we are going to use the triangle way to solve this because we don't know the distance from the midpoint to a vertice. The only information that's given to us is a side length and a height. Again, it's the height because it's 90 degrees here. So one thing I would like to show you is here is one of your triangles. Base times height divided by 2. Remember, how many triangles can we create? It gives it that to us in the problem. 6 matching triangles. So those 6 triangles are all equal to each other. Obviously, mine are not in this drawing, but we know, and it's assumed that they are matching triangles, are equal triangles. Go ahead and solve for the area of this hexagon. All right, let's go ahead and find or explain how we solve for this. So area of a triangle equals base times height divided by 2. Area equals, the base is 4 times the height, which is 3.46, divide by 2. Go ahead and solve for that. 4 times 3.46 equals 13 8400ths. Divide that by 2, and I get area equals 6.92 inches squared. Again, this is just this triangle. We know that these are all equal to each other, so I have to multiply this by 6. So the area of the hexagon equals 6 9200ths times 6, which we should get 41 5200ths inches squared. All right, in part 3, we are going to talk about octagons. Octagons are 8-sided shapes. 1, 2, 3, 4, 5, 6, 7, 8. All right, it says decompose the regular octagon into triangles to find its area. Round your answer to the nearest whole number. Find the area of one triangle by multiplying it by 8 and find the area of the octagon. So again, just like hexagon, there are two ways to solve this. In this problem, it wants to solve this with triangles because of the information given to us. I want to show you both ways to solve this, though. This is our midpoint. If that is our midpoint, we can create triangles. And all of these triangles would be congruent triangles, meaning they are the same size because our side lengths are the same. And from a vertice to a midpoint, it's the same distance. So all of these have the same side lengths, so they are all congruent. So if we can find the area of one triangle by finding the base times the height and dividing that by 2, that would be the area of this triangle. Then we multiply it by 1, 2, 3, 4, 5, 6, 7, 8. Get the area of the octagon. The other way to solve it, we can decompose this into two trapezoids and one rectangle. I will say this way is way more work because you have to find more things. This, finding the triangles, you only have to find the area of one triangle, then multiply by 8. Here you have to find the area of this trapezoid, which is equivalent to this trapezoid. And then you have to find the area of the rectangle. But if we were just given like this information over here, we wouldn't be able to find the area of the octagon using this decomposed method because we don't know the distance from this vertice to this vertice. It doesn't go through the midpoint. But it is one way to solve for the area of an octagon. Let's go ahead and solve this problem. Why don't you give it a try on your own first, and then we will go over it, or I will go over it, an explanation. Hopefully you've given it a try. Let's go ahead and decompose this regular octagon into some triangles. So if I draw a triangle here, that point right there is the midpoint. Bring it back to another vertice. Here's one triangle. That triangle's base is 6 8/10. The height of that triangle is 8 2/10 centimeters. So the area of the triangle equals base times height divided by 2. So area equals 6 8/10 times 8 2/10 divided by 2. We can go ahead and plug that in. We should have 6.8 times 8 2/10 equals 55 76/100. Divide by 2, we get 27 88/100 centimeters squared. That is the area of one triangle. So what are we going to do then? Yes, you got it. If you said multiply this by 8, you are correct. And that is because that's the area of one triangle. We have 8 in total. So 27 and 8/10 times 8 equals 223 and 400 centimeters squared. This is the area of this octagon. At this time, let's go ahead and regroup here, talk about what we did today. That is finding the area of hexagons by decomposing them into 6 equal triangles. To find the area of a hexagon using 6 triangles, it has to be a regular polygon, meaning the side lengths are all equal and the angles all have an equal measure. That's the only way it works. So if it's a regular polygon at 6 sides, which is a hexagon, then we can decompose it into 6 triangles, or we can decompose it into 2 trapezoids. When finding the area of octagon, we can decompose it into 8 equal triangles or 2 trapezoids and a rectangle. Just like hexagons, this only works if it is a regular octagon, meaning all side lengths are the same and all angle measures are the same. All right, at this time, if you feel comfortable, you've completed all the guided notes, please show it to the sub. Then you can get started on today's homework, which is Math Excel 13-5 Polygons. I hope you have a wonderful weekend, and I will see you when I return on Thursday. Bye, everyone.